And to divide, we like to flip that second fraction and multiply. If you're not feeling so certain about seeing just that whole number 5, what I would recommend is make it look like a fraction. So any whole number, we can make it a fraction by using a denominator of 1. So 5 over 1 divided by this fraction. I'll flip and multiply, so the first fraction will not change. It's the second one where we'll use the reciprocal. X third, y third in the numerator, 5y to the third plus 3x to the third in the denominator. How do I like to finish? Can I factor? And then is there anything that I can cancel? 5 cannot factor. 1 cannot factor. X to the third, y to the third, again, I could write it in expanded form like x times x times x times y times y times y. I could do that, but it's not the most helpful thing in the world, in my opinion. If it's helpful for you to do it, then definitely do it. If it works, you do it. That's all the reason you need to have to do something, is because it works. I'm going to skip it for this problem and hop down to this denominator and say, is there anything that I can do to factor this one? I have a couple of ideas. First, I want to think about GCF. Do I have any factors that are common to both of these terms I can bring out in front? That answer is no. Is there any other type of factoring I can do? And I'll be honest with you, I'm spotting a y to the third with x to the third and thinking, is this maybe a sum of cubes that I could factor? I haven't seen one of those in a while, but the coefficients are showing that it really is not a sum of cubes. If it was sum of cubes, I would be able to write these terms with an exponent of 3. I'd be able to fill in these boxes, and definitely an x could go in there, but I don't have any number to the third power to equal 3, at least not a rational number. And same thing with the 5y to the third. A y in that box would fit nicely, but no number in here to the third power will equal 5. So it turns out that this is really not a sum of squares. There's no type of factoring that we can do with this 5y to the third plus 3x to the third. So no factor, and also no cancel. I'm not going to try to cancel this 5 with this 5, because the 5 that would cancel with this 5 would be a 5 that is out in front of parentheses, like a GCF, not a coefficient of just one term. So we couldn't really do any factoring, and we couldn't cancel either. I need to finish it by just cleaning this problem up so it doesn't look like a multiplication problem, but looks like the result of the multiplication. 5 times this numerator, 5 times x third y third is 5x to the third y to the third. That's our numerator. In the denominator, 1 times this expression. And anything times 1 is that anything, so it's 5y to the third plus 3x to the third. There's our answer. At times with these problems, you might feel like there are more things I have to do. Like, is this final answer, is it really more simple than the problem that we started with? And that's completely a matter of opinion. And I would venture to say that there are some problems that our answer does look more simple. There are even going to be problems where our answer, even though we simplified it, ends up looking a lot more complicated. But I just need to remember my steps. And if I think about doing the steps, then I'll stay on track, and I'll be prepared for an answer that maybe looks a little bit more complicated and makes me feel like or think that there are more things to do, but I'll know that there is nothing left to do. So my steps were parentheses around numerator, parentheses around denominator, and work these as two separate problems. If I get to a part that I don't have anything to combine, then I leave it, nothing to do. Denominator, I have fractions to add, so I pulled that problem off to the side and worked it. Then I bring it back and write it as a division problem, flip that second fraction, and I think about, can I factor, then cancel, and I clean up my answer, and there it is. Okay, I hope this has been helpful. If you're curious about why this video looks different from all the other ones, it's because I'm at a math conference and I don't have my full setup, plus my computer crashed last week, so I've had to try a little bit of a different approach. But here is where I am right now. I'm in my hotel room, and this is, hey, there's me. This is Las Vegas.